Hey everybody. Greetings from the living room. Let's talk about naming compounds. I wanted to give you a couple pro tips that can help you as you get ready for your quiz. So I've got a couple challenging compounds to name. First one, NH4NO3. This one is all nonmetals. Oh, it must be covalent. But be careful. Remember, NH4 ammonium is one of the only positive polyatomics. So always when you look for these, look at compounds, keep an eye out for polyatomic ions. So you know that ammonium is a polyatomic ion. How do you know? Check your periodic table with the ions. So there should be links to it in the last Chem Diary page. It's also in the Chem Links. So here it is, NH4 ammonium, okay? And NO3, you go, oh, that's one of those weirdos, that's nitrate. So both of these are polyatomic ions. And what they are is they're ions made up of many atoms. They're covalently bound to each other. And then they're attracted to each other with an ionic attraction. And it's really because of the positive and the negative. Remember, opposites attract. It's called electrostatic attraction. It's the reason why ionic compounds stick together. So this is an ionic bond. And you just name the ions. Ammonium nitrate, voila. And remember, between polyatomic ions. I forgot why I wrote that, but there it is. It's an ionic bond between polyatomic ions. Got it? Okay, another one. Ooh, AlNO3. Al is a metal. There it is. There's that polyatomic ion. This is going to be an ionic bond between a metal and a polyatomic ion. So let's put it out here, Al3+, and you go to your periodic table, and you can see that aluminum forms a 3+ charge. Or you could look at aluminum and see normally it has 3 valence electrons, and you know it's going to give away 3 to make an Al3L+. So you don't even necessarily need the ion chart. You can figure it out for yourself. So each of these aluminum 3+ is bonded ionically to 3 nitrate ions. And they form like a 3-dimensional crystal. So as you're making your crystals, think about how it's a bond between a positive and a negative. And they form and they form and they form and they form in this 1 to 3 pattern, and they make really cool geometric shapes. Okay, cool. And you just name the ions: aluminum nitrate, AlNO3. Now the tendency is once we start doing covalent compounds is to try to do aluminum trinitrate. Resist the tendency. Okay, let's do this one here, H8C3. And what you got to do is, all nonmetals, no polyatomics. This is a covalent compound. Because covalent compounds are so weird, they can bond multiple ways, we have to name the number of atoms. So this is octahydrogen tricarbide. Remember the second atom, you change to "ide." If you have multiple atoms, to just go like hydrogen, trihydrogen, dicarbon, and then tetrachloride. So the last thing is going to be, the last atom is going to be ided. Okay. Last one here, AuCl3. Au. So you go, oh, okay, it's Au. That is Au3+ and Cl. There's 3 of these Cl's, each of them is Cl-. Once again, you could figure this out by seeing that chlorine has 7 valence electrons. Normally, it just wants 1 more. So the ion is going to be happy when it has just 1 more electron. So, FYI. You go, okay, it's gold chloride. But wait, it's a transition metal. It's in the middle. It can have more than 1 possible charge. So what you got to do is look at the chart in the middle, and if there's more than 1 version, you have to say which one. Is it gold 1 or gold 3? And we know since it's +3 charge, there must be, since there's 3 of these, this is -3, this must be +3. So the compound is AuCl3, gold 3 chloride. And remember, the 3 does not refer to how many chlorines. It refers to the charge of Au. Okay? Cool, there you go.